Hi, I'm Raul Medeiros, and today I will be presenting you our work called Assisting Mentors in Selecting Newcomers' Next Task in Software Product Lines. This work was carried out by Professor Oscar Diaz and myself at the United Research Group at the University of the Basque Country in Spain. Okay. So let's start with a quick introduction to software product lines. Software product lines follow the typical product line approach, and their main goal is to support or enable the systematic reuse of a whole family of software products. That is, software products are quite similar, but with different aspects of functionality. So as you may know, software product lines are divided in two phases. First, we have the domain engineering phase, where the common platform is built, and there the feature model is modeled, and the domain implementation of the whole platform is implemented. Then, in a second step, or in a second phase, the application engineering phase, the engineers derive or create the different products of the software product lines. To this end, they take the customer needs, and based on that, they specify some requirement analysis that serves for creating a configuration of the feature model that was created in the domain engineering phase. And with that configuration of feature selections and the common implementation assets, a product is derived with a transformation of the code, obtaining a product that only satisfies those customer needs specified at the beginning of the application engineering phase. In software product lines, features are very important and play a key role. And features are functional abstractions that serve to communicate reasons and distinguish between the different products of the product line. I wanted to emphasize the concept of the feature because our solution is built around this concept. Now let's move to the process that this work tries to support, that is the onboarding of new people into an SAP company. So what is the onboarding? The onboarding is defined in the literature as the process of incorporating a new developer, also known as a newcomer, into a software development team. This is not rare or strange in the software teams, because in the software area, it occurs quite often. Also, one of the, I have to mention that onboarding depends to a great extent in the context, and so there is no solution that it fits all the software contexts that are available in the software companies. And apart from that, one popular approach to cope with the onboarding is mentoring. And mentoring consists of connecting a senior colleague, also known as the mentor, with the newcomer. And then the mentor will lead the newcomer through all the onboarding process that he has to suffer. Okay, so I mentioned that the onboarding is contextual. We analyzed different barriers that the newcomers faced in 3 different software areas or software practices. First is global software development, the second agile software development, and the third one, what is the topic of this work, software product line engineering. In the case of global software development, we found that cultural differences, geographical dispersion, communication problems due to the different locations and time zones, and the inability to make a good remote mentoring were the most common barriers. In the case of agile software development, we found that embracing the newcomers found some difficulties embracing the agile principles. And apart from that, also, they have some problems changing their mindset because they were not used to being more independent and assign to themselves the different tasks. And in the case of the software product line, there is no any work analyzing these barriers. We try to argue them in the paper. So first, we have some communication issues because there are 2 different teams in the software product lines. First, the domain engineering team and the application engineering team, both with different goals and agendas. So the newcomer has to cope with communicating with one of the other team. Apart from that, they have to embrace the reuse, at least to reuse and create a new product or develop for reuse. And finally, in the technical aspects, we think that there are 2 main barriers. The first is the scope of concerns that they might face, because in a software product line, there are a lot of concepts to face because it's a whole domain, not a single product. And the one that we try to alleviate or improve in this work is that of the understanding the program structure. The most common approach or most popular approach to implement software product lines in the industry is the use of pre-compilation directives, that are annotations that are inserted in the code to enclose the different code of each feature. And it has been demonstrated in the literature that it hinders the comprehension of the code. So what do we think that a mentoring approach in a software product line environment should be? First, we think that it should be guided by the features, because the features are very central in a software product line, and that the mentor should select those features that the newcomer must work with. Moreover, we think that features are well defined and are known by the mentor and easily to understand by the newcomer, so they might serve as the middle ground. So we think that a good path for a newcomer would be that of starting with a feature that he understands easily, and step by step, changing from one feature to another, finally understand the whole of the software product line. So we wanted to assist the mentors. Well, sorry, no. So the mentor has to select the different features, or the most appropriate features for the newcomer. But however, this is not an easy task. There are a large number of features in the software product lines, usually hundreds or sometimes thousands. So it will be time-consuming, and mentors tend to be busy people with tight agendas, and their time is quite valuable for the company. So our goal, or the goal of this paper, was to assist mentors in selecting the next appropriate features for a particular newcomer in a software product line environment. In this sense, we tried to answer this research question. That is, how would a feature-driven onboarding intervention for software product lines organization might look like? And here is where recommender systems come to the rescue. Recommender systems are an established approach to cope with a large set of resources. In our case, would be the software product line features, where users, that is the mentor, have difficulties or problems to find the interested items that will be a recommended feature. So in general, our vision is that the recommender system will be able to predict whether a particular feature would be fitted or not to a particular newcomer based on his background. And we distinguish two different backgrounds. If the newcomer comes from another team of the software product line company, then we use the code that he previously has implemented in the other team as his background. And if they are external, then the newcomer should have to select a first feature that will serve as the background of the newcomer. So recommender systems comprise three different components, main components: the content analyzer, the profile learner, and the filtering component. The content analyzer is in charge of building the profiles of the items that must be recommended. In our case, that will be the features of the software product lines. The profile learner is in charge of constructing the profile of the user that must receive the recommendation, that in our case is the newcomer profile. And finally, we have the filtering component that is responsible of comparing or exploiting those profiles and recommending the most appropriate item to the user. So we implemented those three components in a proof of concept or prototype called Recommender, that is based on a similar project detection tool called LastCat, and our Recommender tool works for software product lines implemented by Pure Variance Variability Manager. So first, in the content analyzer part, what the Recommender does is to take the software product line code base and extract the code base of each of the features. As I mentioned, each feature is enclosed by precompilation directive, so we extract that code and build different code bases for each of the features. Then we process them with topic modeling analysis. Topic modeling is a quite popular language processing, natural language processing technique that tries to discover abstract topics from a collection of documents. In our case, those documents would be the feature code bases, and the topics are inferred from the identifiers of the variable names, comments, methods, or classes names. And what we obtain at the end of this process is a list of feature topic probability distributions, which each of the items in the distribution describes the probability of one feature to belong to a particular topic. For example, in the slide, we can see that feature F1 has a 20% of probabilities to belong to topic 0. Okay, so now let's move to the profile learner. The profile learner is nearly the same, that works nearly in the same way that the content analyzer. We have the newcomer code base, and sometimes will be their previous code, and in other times the feature that was selected by the mentor. So we apply topic modeling again, and finally we obtain another probability distribution that depicts the probability of the newcomer or newcomer profile to belong to a particular topic. And finally, in the filtering component is in charge of exploit those profiles that we have created during the content analyzer and the profile learner. And as I have mentioned, both of them are probability distributions. So what the recommender does is to take those probability distributions, and through a similarity technique called Jensen-Shannon divergence that is used for probability distribution similarity calculation, we obtain the similarity between the newcomer profile and the different features of the software product line. And we order them based on the similarity that algorithm returns to us. And that will be all with the recommender tool. Now let's see how we validated it with a formative preliminary evaluation. So we evaluated recommender with Walkline software product line. That is an open source software product line for web annotation extensions. Walkline consists of 80 features, from which 60 are optional. And as the users, as we didn't have access to real users or real newcomers, we used the Walkline's 60 optional features as surrogates for 16 new newcomers. So it will be to simulate the situation where 60 new newcomers come to the company or to Walkline, and we have for each one a different feature assigned as their background. And to evaluate the results of recommender, we asked to the developers of Walkline to construct a ground truth or an oracle consisting of a feature-by-feature matrix, where each feature pair has had a value of similarity ranging from 0 to 3, where 0 was totally dissimilar and 3 was near identical. So what we wanted to know or to validate was if the results given by recommender to what extent matched the similar features ranked in the oracle. So we resorted to 3 information retrieval ranked metrics as a way to measure its performance. And concretely, we used precision at key, normalitative discounted cumulative gain, and the first false positive. Precision at key refers to the proportion of recommended features or items in the top K results that are ranked or rated as similar in the oracle. NDCG, measures the quality of the ranked results in terms of how well they are ranked in the recommendation and the results. So if we have those features ranked with a 3 or 2 in the first results, then NDCG will have a good result. And last, we used also first false positive that measures where is or in which position do we have the first wrong or recommended feature. So in which position do we have a feature that is ranked in the oracle with a 0. And what we obtained these results. In the case of precision, we limited it to only to precision at 5 because we think that in each step, the mentor only has to check a pair of features because he only has to select one of them. And we obtain a 0.67 precision that is not very good, but at least we think that is quite promising. In the case of NDCG, we obtain, I will say that quite a good result with a 0.87, and that means, that we have ranked those features with 3 or 2 ratings, so the features that are rated by the developers of Walkline as similar in the first results, in the first positions of the recommendation. And last, in the case of first false positive, in average, all the recommendations result that in the 4th position, we had some false positives. That is, we had position in the 4th rank, a feature that wasn't similar to the one that was built as the newcomer background. This could be seen as a bad metric, but if you take into account that in average only 7 or 8 features were marked as similar for each background feature or background newcomer, I think that can be seen as a more or less good metric. So to conclude, we presented a feature-driven mentoring approach tuned for software product line environment. We support this approach by an implemented proof of concept called Recomentor. That is a recommending system built on the top of LastCAD and implemented for software product lines working in the peer variance variability manager. We implemented the recommending system using topic modeling, and as a proof of value, we conducted a formative evaluation with 3 information retrieval ranked metrics. As I said, we think that are promising results, but yet very limited due to the fact that we didn't have access to real newcomers, and we did use some surrogate features as virtual newcomers. And for feature work, we plan to extend the evaluation of Recomentor to other software product lines, or at least to real newcomers and real mentors. We also want to implement the user interface of Recomentor because right now it is a Python console application. And we also want to improve the elaboration of the profiles, because right now it only is based on the code of the features and the code of the newcomer. And for example, we plan to include some popular metrics of the software product lines like feature scattering or feature tangling. So that's all. Thanks for your attention. Well, the implication would be that the newcomer will have to explore or work with a feature that is not similar to his background, or at least that maybe the mentor will spend more time thinking if it is a good feature to recommend or not, I think. So the spend will be that that the newcomer will have to spend more time working with that feature, and the onboarding process or the ramp-up time, that is the needed time to achieve a good productivity, will be longer. Yeah. Well, as I have mentioned, we plan to extend the evaluation, so we want to see how well they work in a real situation, because right now, and with in a real situation, because we created an oracle, when the developers of GoCline created an oracle, and maybe it could be biased due to their experience or their lack of experience. So I think that in a real situation with real newcomers or real mentors, we will be able to measure if the results are really promising or are good or are really not so good.